Right. Good morning, everyone. In the previous sessions, we are start with the collection framework, right? And we are completed with the vectors and the array list. Both are the same only, but the difference is the memory allocation with the vector and the array list will be the difference. Vector every time doubles the allocation space to the allocation space to the container, and array list will be some small, and array list will be the latest one, vector will be the old one, right? In the today's session we are going to discuss that stacks. Suppose you have a prior knowledge on data structures in any language, then it will better understand to you, or else we'll discuss good. Firstly, there are the two data structures we are calling it as stack and queue. Stack is like a array only, but the we are discussing the concept. That means stacks follows the one principle of last in the first out. That means which was entered into a container last will become first. It will be the principle it will follow. Actually stack is not a one predefined. Normal when you are dealing with the data structures and all, you are just following that principle. You are just following the principle which was you are adding an element to the container as a last, it has to become as first. Stack follows the principle of we are calling as LIFO or philo. That means last in first out. Which was entered as last, they has to come first, or else philo. Both are the same. First in last out. Which was entered first, it has to come as last. First in last out. Normally the stack principle and the stack data structure mainly helps to you. Suppose when you are browsing in a Chrome, you are switching the tabs, right? Suppose stack is mainly helps on a undo rendo operations. You are pressing the control Z and control Y, right? Undo and rendo. These operations was performed by using the stack operations. Or else suppose if I browsing something, you have a two tabs here, right? Two ways of navigations. One was the left and right. It is also performed based on a stack also, right? The mainly undo rendo operations you have performed by using stack. Normally how the stack will lies. The stack is simply like an array, but it follows one principle. That principle, which was enter last, it has to come first. Okay, right. Simply, string stack is simply example like if you observe a plate tray or the books in a library, right? Suppose it was one container. In this, you have the different things. Suppose you place a book first, In place of this, you can imagine these all are a books. It was the first, second, third, fourth, fifth. First, you have to know the terminology. Suppose these all are the 5 books. This first book was entered last into this trace, right? And it has to be come first from the trace. If you want to bring the second book also, you have to pull out this fifth one, the fourth one, and third one out, third one out. After that only it has to be pull out the second one, right? In the stack you have some terminology. The element which was last entered, we are calling it as a top or peak. We are calling this as a top or peak. Okay, and suppose you are taking the example of a fixed size stack. That means you are defining size to your stack. Suppose my stack has the only limit of 10 books has the capacity to that stack. Okay, here it will take the dynamic size, but in a normal data structures, if you define any limit to the stack, then there will be a one condition is called stack full or stack overflow. That means suppose you are placing the 10 books in a tray, and if you are try to place the 11th book in that stack, right, then it will be the overflow condition, stack overflow condition. Okay, normally the overflow condition not happens here. Why? Because it is a dynamic stack, it will increments the size according to your elements. But when you are defining a fixed size to your stack, then it will be the overflow condition happens. And is full, there are the methods. Is full also not happen where? Why? Because the increment will be the happen, dynamic size will be allocated, because of that stack never fills. If you fix with a size for the stack, then it will be happen. Next is empty. Is empty is the condition. You have to check your stack is empty or not. That means a empty trash. Simply like a your array will be the no elements, length of the array will be the 0, anything. Stack empty. If stack, normally there are the operations push, pop. While doing the pop, one condition has to become, that will be the stack underflow. That means your stack is empty, your stack is empty. At that time also you are try to pop it, at the time also you are try to pop it, then the condition will be the underflow, stack underflow condition, we are calling as a normal terminology. In the push, in this chance to overflow, that means if you are fixed with the stack size, then it will be the, maybe suppose you have the 10, you are try to incrementing as 11, then it will be the overflow. Push means adding element to the stack, pop means removing element from the stack. If you perform the push, if you perform the push, that means it will appends an element at the last. Okay, appends an element at the last. And if you pop, removes element from the last. Push is for adding an element, pop is for removing an element. Both are work from a rear end, we are calling it as a rear end, right? From this rear end it will perform adding operation and removing operation of a stack, right? These are the operations you have. And is empty, can your stack is empty or not. Suppose if your stack is empty, then you are try to pop it. Normally we are calling as a underflow condition, but your Java programming raise an exception called empty stack. Empty stack exception. Empty stack exception. You have to understand the workflow, how the stack will perform. Then all are the methods only now, then you can easily do it. But you have to understand the terminology and what will be the cases. The major terminology will be the pop, push, and another method is there. It was the peak. Peak, it will returns the top element. Okay, peak returns the top element of your stack. These are the basic operation you can perform, and in any thing, in any data structure also you are performing this, adding an element, removing an element, and checking the element is there or not, like that, right? Right, next we'll go with the implementation part and another methods. Search is one method. That means you have to search an element exists in your stack or not. Search. If element is there, it will return the index. Index. Normally, it will take index. It was a 1, 2, 3, 4. We'll observe that, right? And okay, we'll go with the implementation part. New class. My class name will be the stack operations. Right. Normally, how can I create a stack? You can directly create a stack class by using the stack class, or by using the list interface also you can create stack s1. Suppose I want to mention a type of data I can store in my stack. Suppose I want to store the integer type of data. It is a wrapper class, we are calling it as integer. Suppose my stack is s. Okay, new. You have to import the stack here. It will be from java.util.package, or else you can simply place the star. Right, I am created my stack. Now what I do, suppose I want to add an element to my stack, then s1 dot push, add element to stack, push method. Okay, s1 dot push. In that you can place the element. Suppose I want to place the 12, then I can pass the 12. Suppose you want to pass any string, then you can change here to the string data type and you can pass the string here. Or else you want to store multiples strings, integers and the doubles, anything, then you cannot place the type here, it will take the object as a type. Okay, s dot push, and here I can print my stack s dot stack after one push. After one push you can't observe any difference. Why? Because only one element, right? Because of that you can't observe anything. Now s dot push of 24, right? S dot push of 24 stack after second operation, second push. Suppose second push my s, I'll do one thing, I can push the by using for loop for I in, for int I equals to 15 to I less than or equals to 20. I can push the I value I plus plus s dot push of I, right? Here my output will be the only 12. Here my output will be the 12, 24. It will append at the last. Okay, 24. And here my, after completion of this step, my output will be the 12, 24, and start with the 15, right? 15, 16, 17, 18, 19, and 20, right? And 20. If I print here sys out of sys out of stack after multiple push, okay, multiple push, yes. Suppose after deleting a one element, stack after deleting one element, or else you want to delete, suppose s dot pop, s dot pop, it will returns or it will delete an element. Suppose I'll try to, what element it will delete it. Okay, first thing I'll done to this, I'll run once. Right, after one push 12, second push according to me 12, 24, and 12, 24, 15, 16, 17, 18, 19, 20. When I perform s dot pop, it will remove the last element. Okay, suppose again I'll try to perform this out, I'll print the after one element deletion my stack, I'm printing my stack, and after that I have to check the what is the peak value. Okay, peak value, if deleting the 20, then peak value becomes 19, the top will be the 19. So s dot peak, okay, s dot peak. Here I have to get 19 as a value. if you observe, the pop also returning the top value, peak also returning the top value, but the difference is pop deletes the pop value and return, and the peak only show the top value, not delete it. Suppose I'll check it once. After checking the peak, okay, right, it will displace that 19. After deletion of my stack will be without 20, and 19 is peak value, and after checking the peak 12 exact before the checking of the peak. That means peak only returns the value, pop delete and return the value. Okay, right. And I have to search the 17 is in the stack or not. So s dot search search of my value will be the 17. Okay, then I can observe what will be my output. What it is, it will return the 3. That means location, it is the first location, it is second, it is third, it is fourth, it is fifth, it is seventh, sixth, seventh. Like means order, it will return the order where it is in your stack. Okay, like a priority, it will be the first priority, second, third, fourth, fifth, sixth, seventh, like that. Search. And once I'll check in the pop operation, I'll try to mention one index. Okay, sysout of s dot pop of file, right? Then it will throw an error. Why? Because only pop operation has to be performed at the last. So but I'm trying to removing at the fifth location or something. Because of that it will throw an error, right? And another operation is empty. You can check your stack is empty or not. Now what I do, by using the for loop, by using the while loop. Why? Because while my s is not empty, not s dot is empty, I can perform the stack. Okay, while s dot is empty, I can perform pop operations. Okay, s dot pop off, done. If this condition true means it will not execute the pop operation, right? Suppose this condition true means the stack will be the empty. If the stack is empty, I'll try to perform s dot pop. Then it will throw an stack empty exception. What is this? Empty stack exception. Okay, when your stack is empty, you are trying to pop an element, it will throw an exception, empty stack exception. You have to remember, right? This is all about the stack. You can check the is empty and search and pop, peek, pop, push, like that, right? Next we'll go with the linked list. Normally these are all called as we are data structures, DSA. In that by using the classes we can create manually the nodes and access, but the collection framework simplifies the process of it and giving the built-in data structures to you. That is the thing. Now linked list. First, what is the linked list is we have an array. Linked list also simply like an array, but the difference is what is actually an array means. Array stores the elements in a continuous memory location. That is the difference between array and the linked list. Linked list stores the elements in a random location and maintain the order. Maintain the order. Suppose that means suppose I have a node. I have this node. I have this node. Normally the basic linked list is a single linked list, but here your Java collection applies the double linked list. Okay, normally a single linked list has the two parts. Like a array, it has the two parts. One will be the data, okay, address here, address and data. One part is for data and one part is for address. That means address of the next node. We are calling this as a node. You have a two parts. One was for data, one was for address, which has to store the next element location. That means suppose my element is this one is at 100th location. My next element it can be stored in the 150th location. Normally I am storing the integers only, but it will store in the 150th location. Right, 150th location. I have there also one node. Here also I have a data part. It was the one, and it is the address of suppose it is the 2 and it is the data. Actually 2 is the data and this is the address part. That means it can store the 150 value here. Here it will store the 150. That means address of the next node. Here but the last node can store the null value. That means if in a linked list last element doesn't traverse to the beyond that, so last element address part will be the null. Okay, it is basically a single linked list. That means one way of traversal. Suppose I have this and I have another here. It is another node and I have another node here. All are will be the links. Why? Because suppose if you are storing the hundreds of integer elements, then you have to allocate. If you are storing the array type, then you have to allocate some memory continuous. That means suppose 100 location to for the suppose it will occupy for the 500 location. Okay, that means you have to be search for the that much of space in your memory for storing that 100 element in a continuous memory location. But when you are dealing with the linked list, no need for that. If you have the space at one location, you can simply store that and link with the previous one. If you have at another location, you can store there and link that. Like this, in a random positions, you can store it and link with the existing order. That is with the benefit with the linked list. But here in the collection framework, your linked list follows the double linked list. Double linked list means in the single linked list only you can traverse the one side. That means in the this side or this side. But in the double linked list, your node contains two addresses. One was the previous node, one was the next node. That means you can traverse in them two ways. Right? Like your tab here. In this way, in this way. Okay. Data here, data, and here previous node address. Here it was the next node address. next node address. By using this you can traverse from this. Suppose in the single linked list you are at this location, you are at this location, it is possible to go to this location? No. Why? Because this node doesn't know the information of a previous node. Based on the addresses only it can traverse. Suppose I am at this location, I can find, I have the 150 address, so I can just traverse to the 150 addresses, but I don't know where I have to traverse. That means only one way of traversal will be happen in the single linked list, but in the double linked list you can traverse either this side or this side. That means you can traverse from previous node, current node to the previous node, and current node to the next node. In the two way of traversing will be possible with the double linked list. That double linked list will be used in here linked list collection. That is the major thing. And what are the operations? Suppose in the list you can append. How can you add an element? Suppose if you are simply perform add, it will add an element at the last. Add element at the last. Add element at last. Add element at last. Suppose if you wish to add at first, then add first. Add element at first. Add last also is there. If you have to add at the last. And remove is there. Remove first is there. Remove last is there. Like this. You have a different methods like this. And also add last is there. Add first is there. Add is there. Add at particular index is also there. Index is from, suppose you have the multiple nodes, every node will be one index. That is the thing. We'll go with the execution part. New class linked list. How can I create an linked list? Is linked list. Now I can go with the strings. String my list equals to new linked list. We are calling these braces as that means less than and greater than symbol as generics. Okay, we have to import that linked list. Import java dot till dot linked list, right? Okay, string capless. Okay, and the thing is, suppose first I can print my list. Sys out. It will print like a simply array, simply an empty array. Okay. And suppose I want to add an element to the list. List of sorry list dot add. How many add methods I have? Add string e, add int element, add all collection. Add all means collection you have to add. Add first, add last. Right? These are all the methods I have. Suppose I can go with the add. I can add the one element. It is 12. Okay. 12 is I can go with the hello. Right? And I can print here sys out list after adding an element, and simply same way list dot add of again hello one. Okay. And again I'll print that sys out of list, sys out of list. Right. Once I'll run this, first it will return the empty array and hello one. If you perform add, it will appends at the last. Okay. Suppose you are wish to add at first, list one dot add first, add first. In that add first you can add an element at right, add first element added at the first location. Okay. Suppose you want to add at a particular index, that means I can add at the hello place. List one dot add of my hello place index will be the one, right? One comma uh, Sita. Okay. Okay, I have to print it right. Sys out. I can print my list. Sita will be added at the index one location. Suppose you want to find the index of anyone. Sys out list dot index of hello. Right. Hello. Index of hello 0 1 2. Index of hello will be the 2, right? Next, the same way, if you want to remove an element, list one dot remove, it will return the first element. Once I'll check. Right. It removes the first element. If you want to remove the last, remove last. Okay. Suppose a particular index you can remove, place the index and the remove it. Okay. Suppose a remove of 2 like this, remove of 2, remove of 3 like this you can do. Right. These are all the remove methods. Suppose you want to clear the all list, then a list one dot clear is a method. For a vector also the same, for the array list also the clear. Add first, add last also the same. Sys out all the operations we are discussing in the vector, that all the things of list. it will return an empty list. You can check the is empty also here, and you can check the one element in the list also. You can check one element is in the list or not by using the contains. I can list out the some methods here. Um, index of why this index of will need returns the index of element in a list. Next thing, and the last index of what it do is returns the, suppose I have a multiple elements, I have multiple same elements, returns the last found element, returns the index of last found in the multiple elements, right? And contains returns true or false based on the element lies in the list or not, lies in the list, right? The same way get, okay, in the get you can mention an index or an value, you can mention the value, it will return the index of the, suppose normally you can write a array of 1, array of 2 like this, right? Here you can mention an index, it will return the value at that particular index. I can show list 1 dot get of list get of 3, 2, 3 will be returns a false. I can comment it. Hello one. Okay, normally if you have to write a list 1 of 2, list 1 of 3, list 1 of 4 like array, but here you have a method of get, right? That is the difference. And the methods I missed, like this adding, pushing and all the things, this is all the linked list. What are the methods we discussed in the vector is all are applicable to the array list and the linked list also, but the concept is different. Those are stored at continuous memory location, these are stored by random locations, okay, that is the difference with it, right? With this we can end up with the list interface collections. In the next session we are discussing queues, sets and queues, okay, and after that we will discuss the maps, right? Thank you.